Okay, so here's another video that for some may just be a review of really from middle school science again. We're just going to change the symbol of what density is, because a lot of times in middle school science they just call density D, but here in upper level science we do have a special symbol for it. So density, right, is the mass per unit volume of a substance, right? And we give it the special symbol rho, and that's a bad rho. So the way to explain rho, right, it's basically just a curvy P, right? So density is mass over volume, right? I don't know if you remember doing things like density island and stuff like that. So it's like mass, volume, density, and that just helps you. So this is what we call the density triangle. Just helps you solve the equation for different factors. Now it's an important characteristic of substances because it's going to determine if objects sink or float. And we'll get into that in a little bit when we dive more into fluids. Okay. Again, this is just just a simple table looking at just different densities of solids, liquids, and gases. A couple of the main ones we'll look at, really, it's water, but do pay attention because you would have to multiply this by 1,000 to get kilograms per cubic meter, right? So each one of these you have to multiply by 1,000. So for example, if we're looking at aluminum, we would use 2,700. If we were looking at brass, we would use 8,440. It's just how the chart in air 1.29, right? So this is just how the chart in the OpenStax textbook works out. So notice that the density of solids and liquids are comparable because their atoms are in close contact, right? So they're in closer contact than they are in gases. Whereas, why is that true? Because there's just a lot of empty space in gases, right? So the molecules are spread far apart. All right, so here's just an example problem. It says a reservoir has a surface area of 50 square kilometers and an average depth of 40 meters. What mass of water is being held behind the dam, and where the density of water is 1,000 kilograms per cubic meter. Okay, so we're just going to use density as mass over volume. Okay, and we're going to say that mass is density times volume, and so it's going to be 1,000. Right, which is our density. Now we do have to do a conversion factor because we have 50 square kilometers. So we need to convert this to square meters. So we're going to do 1,000. There's 1,000 meters in 1 kilometer. But because we have two of them, we have to do this twice. So we're going to square that. And so we're going to have an area of 5.0 times 10 to the 7th square meters. Okay, and so basically if this is our dam, right, here's our water, right, and so we need the volume of this water, right, and so that's going to be area times height, and so that's what we're going to do here. So this is the area, and so now the height is going to be 40 meters, so we're going to multiply all that by 40, and we're going to get a mass of 2.0 times 10 to the 12th kilograms. Okay, and so that would be the mass that's being held up by this dam. They could ask you a question about, what's the weight of the water? So you just multiply this by, 9.81 to get the weight. Okay, so now we're going to start talking about some newer concepts. And the first one we're going to deal with